Let's practice naming ionic compounds. Make sure you have a periodic table handy and feel free to pause the video so that you can try problems by yourself first. This first one, the first element is lithium, and because lithium is not in the D block, we just name it lithium. The second element is oxygen, so we change the second word to end with oxide. Hershey, not in here, okay? Take it elsewhere, please. Great time. The second one's a little more tricky. Ni is nickel, which is in the D block. So we know it's nickel, but because it's in the D block, we have to have the charge in Roman numerals. Now the second word's going to be chloride, so we'll go ahead and fill that in. Now in order to figure out the charge on the nickel, we have to think about the charge on the chlorine. Chlorine has a -1 charge, so that means we have in total a -2 charge because we have 2 chlorine atoms. We know that every compound is electrically neutral. Since there's only one nickel, it has to be +2. So we can say nickel 2 chloride. Now some people will just say that you can undrop and swap. You can take this number and that'll be it, but that doesn't always work. Like in the next case. Iron is one that we have to tell the charge. That's iron something oxide. Oxygen has a -2. That means we have -4. So our iron has to be iron 4. And if you'd taken that 2, you would have said iron 2 and you'd be wrong. Next we have manganese, which is also in the D block. It's sulfide. Sulfur has a -2, so manganese has a +2. And this is potassium sulfide. And potassium is not in the D block, so we don't have to do a charge. The charge on potassium is 1. It's always 1. You don't need to insult my intelligence by telling me that. In fact, I'll take off points if you tell me when you don't have to. Calcium, also not in the D block, so we just do calcium. And iodine becomes iodide. Let's talk about how to go the other direction. So, when we want to write formulas, we have a couple of options. We know that it has to make an electrically neutral compound, and we learned when we were doing the drawings for how the bonds were formed that there's only one way they can go together. So we could do the drawing and figure out how many of each atom we need in order to get everybody happy. But there's an easier way to do it, and it's called dropping and swapping. So make sure you have a periodic table. Barium, first thing we do is we write our ions. Barium has a +2 charge because it is in group 2. So remember when I say write your ions, that includes a charge. And oxygen has a -2 charge. So dropping and swapping, drop means you drop the positive and negative signs. And you swap the numbers. So this 2 goes here, and this 2 goes there. So you have Ba2O2. And then we have to reduce to the lowest whole number ratio. So we can divide both of those by 2, and we can get BaO. Next we have iron 2 nitride. Well, this one tells you the charge of the iron, so you don't have to look. And nitrogen has a -3 charge. So we drop the positive and negative, and swap the numbers. And we get Fe3N2. Next we have lead 4 oxide, so Pb plus 4. Lead is not in the D block, but remember tin and lead are your two exceptions. You have to tell their charge as well. So we drop the positive and negative and swap the numbers. We get Pb2O4. Now that has to be reduced. They can both be divided to give you PbO2. Copper 3 chloride, Cu plus 3 minus 1. Drop the positive and negative, swap the numbers. And last, potassium iodide. K plus 1, I minus 1. Remember, when you swap a 1, you don't write it. It's understood. So Ki.